Okay, so for this part of the question, okay, for this part of the application is like kinematic also. So what they will give you is they will say given, like for example, rate of change. Given rate of change function. Okay, like they give you dr over dt. Okay, R is certain thing, okay? They give you the rate of change function. Okay, then after that, they will ask you, what they will ask? They may ask you to find the R function. Okay, so if they ask to find the R function, so what you need to do is you need to integrate dr over, okay, dx with respect to x, all right? Then you will get a function, then you will get something, then you plus c. So they will give you a certain information in order for you to find the c. So this is something that you have to take notes of. Okay, the second thing is, if they give you the rate of change, like for example, so we have to know what is the meaning of the rate of change. What is the area bounded by this rate of change graph? So you have to know how to interpret this. How do you interpret this area? Let's integrate dr over dx with respect to x from A to B. So what does this represent? What does this represent? Can you tell me? Total. So that is total. Total amount of what? Amount of R for X between A and B. So that is the interpretation. So there are two things that you have to know. So for integration, correct? The application is like that. They will give you the slope function. This is called the slope function, or you can say it's a rate of change function. You also can say slope function. Then you want to get back the original function, you have to integrate. And you have to know that the area bounded by the curve of rate of change represent total amount of R. And these are the limit. Can you? So this is the main concept. That's all. Remember these two. Okay. So the example 10, I'm going to let you look through by yourself. Okay. The moment you see marginal, marginal means rate of change of that something. That is called marginal. Marginal means d something over dx or dt, up to you, I don't know. So marginal cost means rate of change of cost. Marginal profit means rate of change of profit. So this is the meaning of the word marginal. So have to remember the meaning of the word marginal. So example 10, I expect you to look through by yourself. So I'm going to discuss example 5D. I'm going to discuss 5D, exercise 5D question 2. So I give you some time to go through it first. And I tell you, this is a very important question. Okay, 9 marks in your hand. You want it or you don't want it, up to you to take. So I give you 10 minutes to try to solve this problem by yourself first. Then I will go through it. Can or not? Okay, based on just now I explained to you. Yeah. See whether you can do or not. It's more on part 1. Okay. Are you clear? Okay, so start now. Everyone take out your graphic calculator or whatsoever, that one, and try. I forgot to record. Never mind. So is profit not marginal profit? You got this graph? Okay, can someone tell me what is X1 and X2? Can someone give me the answer for X1? Okay, X2 is 954.6. 954.6. X1?
45.39.
45.39. Okay, now. Okay, so we have to be very careful. Why I want to sketch the graph now? Because number of plate must be whole number. Am I right? Number of plate must be whole number. So we have to make a choice. For X1, are you going to choose 45? Or are you going to choose 46? You are supposed to round up or round down. You have to round up. Because if you put 45, the profit will be negative. Am I right? Yeah, negative. So whether to round up or round down is depend on the situation. Okay? And for 954.6, should I round up or round down? So you look at the graph. Should I put 955 or should I put 954? So you ask yourself like that. Look at the graph and decide. So I think the lower one, we have to round up. For this case, the upper one, you have to round down. Lower one, you round up. So therefore, in order to get profit, the number of plate that's produced must be minimum 46 and maximum 954. Are you clear? Okay. So this is very important decision. You have to make a decision whether to round up or round down. Every situation will be different. Okay, so you have to make a decision whether to round up or round down. Okay, then I also want to let you know from here. Any question from here? So if I have a situation whereby, for this situation, I have a situation whereby my maximum, correct, number of plate, correct, is 432.3. Okay, for example. So number of plate cannot be 432, correct? So if I want to talk about maximum profit here, so I cannot take 432.3. So what should I take? Should it happen at here? 432 or 433? I don't know. So what I need to do? I have to test. I see the value, I got A. Then I put 433. I got a value called B. If B greater than A, then I will say this is a maximum profit. Are you clear? So this is another situation. So during the exam, can I give you a function whereby the maximum is not a nice whole number like what you have here? Can. So if you have this situation, then you have to do a check like that. Or you say test or check. Up to you. When you deal with situation whereby the X have to be whole number. The things like number of plate, number of people, always round to the nearest whole number, then decide which one to take. Hello? Do you get me? Okay. So I told you already, this is a very important question. Okay, now we are going to discuss another question. That is question 7 on page. So we straight away do it together. Everyone turn to page 146, question 7. We are talking about something happened to a person boat. Okay. R1 is the rate of the water get into the boat, kayak. Correct? So I straight away key into my graphic calculator. Everyone, please do that. Okay. Then this is leak, rate of leaking. Into the kayak. Okay. Then R2 T is 6 minus 6 e to the power negative 0.1 T. This is rate of what? Bailing out. The person scooped the water out of the kayak. Okay. Okay. Removing the water at this rate. Okay. So now let's go to part A. After 2 minutes, what is the rate? What rate is water leaking into the kayak? So leaking into the kayak, you use R1. Yeah. R1. So you put the time as 2 minutes. Is it 2 minutes? Yeah, 2 minutes. After 2 minutes. So you put 2 there. So can someone give me the answer? Okay, 1.65 liter per minute. Good, thank you. Then how about rate of being built from the kayak? Okay, can someone give me the answer? Okay, 1.09 liter per minute. Okay, I just want you to give some thought to this one. During the first 2 minutes, the water level in the kayak is rising or dropping? Or the amount of water in the kayak is increasing or decreasing? Is increasing. Why? Because R12 is greater than R22. Am I right? Water leaking in is more than built out. Correct? So the water is rising. So is the water level keep rising? We don't know. So we are going to do the next one. Yep. So let's go to part B. Is the amount of water in the kayak increasing or decreasing after 2 minutes? Explain. So I explained already, correct? So after 2 minutes, the water in the kayak is increasing because R12 is greater than R22. Okay, answer already. So it's increasing because R12 is greater than R22. So the first 2 minutes and also after 2 minutes is the same thing. After 2 minutes, that means you just look at the 2 minutes. Okay, then part C. Part 1, you integrate from 0 to 3, R1T dt. So what is the answer? All this you use graphic calculator. Okay, 3.72 liter. Okay, how are you going to interpret this value? Can someone interpret this value? I will say total amount of water, because they say meaning, correct? Leaking into the kayak. In the first, yeah, you have to write down first 3 minutes. Okay, good. Then part 2. Integrate from 2 to 5. R2T dt. So what is it? Okay, 5.27 liter. So how are you going to interpret? Total amount of water being built from the kayak from. Okay, what I can do is, if I want to say is, I can put this as after 2 minutes and before 5 minutes. Or I can say between 2 minutes and 5 minutes. So up to you how you want to mention it. Okay, so I will leave it to you. Yep. Okay, let's go to part 3. Part 3, you all have your graphic calculator. You should be able to work very fast. Okay, if I integrate 0 to 8, R1T minus R2T dt. Okay, so what is your answer? Okay, 5.09 liter. So how do you interpret that? How do you interpret that? Can I have someone who can talk and interpret this so that it can help you to do part D? How much water is in the kayak after 10 minutes? Still remember yesterday when we talked about the lion and the zebra? We said you can do this. You can split this into two parts. Go in this much. Go in. Take away. Go out. Just put it simple like that. So what do you mean by the 5.09? Can someone tell me?
Yes, can I say after 8 minutes, the volume of water remaining inside kayak is 5.09 liter.
Can. Perfectly okay. So I can say amount of water in the kayak after 8 minutes is 5.09 liter. Okay, so if you know how to do this, then you will know how to do part D. Am I right? You will know how to do part D. That is, you integrate from 0 to 10 R1T minus. Okay, you can do it together. You don't have to do it separately. Minus R2T, yeah, dt. Right? You can do it together. So what is your answer? 6.31 liter. Okay. Now, I'm going to extend a question. I can say based on C3 and D answer, can you, okay, based on C3 and D answer, is the amount of water in the kayak always increasing? Can I make a statement like that? Is the amount of water in the kayak always increasing? Explain. So this is the extended question that I can give you. So what will you do if you're given? When I use always, that means I'm talking about like yesterday we talked about the one as time passes. I mean, how hard you work, you won't be able, you will at the end you will sink. Is that true based on this model? Based on the answer in C and D, yes. But if you go to the graph, can you sketch the graph? Yeah, because from 5.09, then after 10 seconds, you go to 6.31. So based on the answer in that, yes. But as time passes, because I don't know what happened after 10 minutes, So what I need to do, I need to sketch the graph. Can you please sketch both the graph for R1 and R2? This is my R1 T, because the limit is okay, wait, I draw it. Okay. Your R1 go like that. Your R2, what happened? Okay, I redraw the whole thing. Yeah. This is your R1 T, and your R2 T go like that. Am I right? Uh-oh. What happened to Miss Doe today? Okay. R1T. Okay. Is T. Yeah. Hold on. I make it a bit further. Okay, this is my R2T. My R2T, the limit is 6, right? My R1T, the limit is 5. So you see, can you find the intersection point? Can you find the intersection point? This is exactly like yesterday we talked about the zebra and the lion, am I right? Can you find the intersection point? Can someone give me the intersection point? Hello? 6.31. The intersection point 1 is 0. There's 2 intersection points. One is here. Can someone tell me the intersection point?
16.09.
Yeah, 16.09. I mean, after 16 minutes, okay, the situation changes. Am I right? So we will say the water level rises, increases. The amount of water in the kayak increases for the first 16 minutes. After that, okay, the amount of water in the kayak decreases. Right? So these are the questions that I will say, when will the amount of water in the kayak decreases? You say after 16 seconds, after 16 minutes. So because after 16 minutes, the rate of build is higher than the rate of leaking. Are you clear? So these are the extended questions that I can ask. You see, different scenario. The thing that we ask is the same thing. Hello? Are you okay? Okay, so the rest of the things you have to do it by yourself. Yeah, every time when you do a certain question, you ask yourself how to interpret that. So the main thing for integration, the application is this. You have to remember these two. That's it. Can or not? So you will have two questions. You have two questions. If you look at your if you look at your SAT practice, you have 2 questions that will deal with all the integration, yeah, how to integrate and so on. And 1 question on still remember the upper rectangle and the lower rectangle. Okay, then 2 questions on application. So chapter 4, 2 questions, chapter 5, 2 questions. Are you okay? So during this Chinese New Year holiday, please, what?